And they have it in their handout on page 23, because if you know all the parts of the ear from the outside to the inside, you actually know the path of sound waves. And that can easily mean that you get like 6 marks for a question like that. And it's the easiest question to answer.
And it depends on how a question is put. It can even form part of an essay question.
It's true.
Pathway and how it's converted into a nerve impulse and working with hearing and balance. I'm just shooting from the hip here now. It's not a tip, but go and practice a question like that.
And the main thing that you need to remember is, if you look at the inner ear, right, it consists of 2 parts. It has here the cochlea, and it has the vestibular apparatus, which consists of your 3 semicircular canals and your vestibular body that contains your saccule and your utricle. So, but that section on top there, the vestibular, this mouse doesn't want to work and show the arrow.
There it is.
Where do you see it?
Now, what do you want to show them?
No, I just wanted to take away the vestibular apparatus so that they know that hearing has got nothing to do with that section.
Those 3 semicircular canals that you see at the top, those rings, there we have it. They constitute the vestibular apparatus. That's for balance. They don't play a role in hearing. Right, let's continue.
Right. So let's see. First of all, it's the pinna. The pinna, it traps the sound waves. And that is why it is shaped like that, so that the sound waves can actually be directed to the auditory canal. And the auditory canal must direct it to the tympanic membrane or the eardrum that starts vibrating. And it has the same as any drum. It starts amplifying sound. Makes
Up to 20 times.
Yes, yes. And then it is carried over to the 3 ossicles. Please, you need to know that these are the smallest bones in the human body: the ossicles, the hammer, the anvil, and the stirrup, or the malleus, incus, and the stapes. And then sound waves go through. Also know that the stirrup makes contact with your oval window, and the oval window amplifies sound up till 20 times more than the tympanic membrane. And then it goes into your cochlea there, and that vibrations that cause the sensory cells in the organ of Corti to be stimulated and nerve impulses. So know that. We're not going to teach you all over again. We're going to tell you what it is and how it is that you should look at it and how it can be asked in a question paper. Lorraine, you'll get your balance.
Balance is the next part. And by the way, this is now about the sense organs. It can be connected to the nervous system, the brain itself. Specifically here with balance, you can be asked which part of the brain controls balance. That will, of course, be the cerebellum. So messages from the center for balance will be, or the vestibular apparatus will be sent to the cerebellum to be interpreted and coordinated. Now, the vestibular apparatus consists of those 3 semicircular canals at different angles, as well as the utriculus and sacculus. Now, inside, or the type of movements that constitutes balance, we have the next slide. Yes, is the position of the head in relation with the ground and the movement of the head. So balance is about being upright or lying down, as well as about how you are moving with relation to the ground. Balance works with gravity. Now, in the semicircular canal, you've got a widening at the bottom that's called the ampulla. And in the ampulla, you've got a structure, the cupula. And if you move your head, the endolymph, the liquid inside the semicircular canal will move. And there you can see what happens. There's your ampulla with the cupula. And as you move and the endolymph moves in this tube, it will cause a sensation, a stimulus. It's a mechanical stimulus. It will cause the cupula to move, and that mechanical stimulus will be interpreted into a nerve impulse. You can see if the liquid is flowing to the right side, the ampulla will be pushed to the right side, and then the message will be sent that your head is moving to your right side of your body. Okay? Then the next one. There you've got in the utriculus and the sacculus, you've got the maculus. And the maculus are actually fantastic. Did you know that you have marble crystals in your head? No, I'm not talking about the marble between the ears. I'm talking about tiny marble crystals embedded in a gel. Those marble crystals are called otolith. It's calcium carbonate, limestone really.
And that they must be careful for, because they can ask that in the Section A type of question for
Yeah.
terminology.
And what happens when you move your head is that these crystals, under influence of gravity, will move. And that movement will be the stimulus, and it will be transferred into a nerve impulse. And you've all had the sensation that you are turning around and spinning and spinning and spinning. And then you come to a standstill, and you still feel as if you're spinning. Please give the otoliths time to settle down, because they're still moving a little bit. Settle down. So go and try it, and you will find how your cupulus and your maculus work. And this is just about what they have to know.
Yeah.
What can be asked?
I think that, first of all, they should know balance, the receptors for balance.
Yes.
And so remember, there are two types of receptors. It's the cristae and it is the macula or the maculae for balancing. And it's all to do, it seems like it's two different things happening, but it's all happening at the same time, because you move your head and your head falls. And why is it that because of gravity it doesn't fall down to the floor? But it's all to do with the balance and all of that. You can see all those little nerve fibers, they come together and they form the bigger nerves, and all these nerves must go now to the brain. And you must also know the section of the brain where this is controlled.
And remember, you've got an awareness that is in your cerebrum, and you've got the control that is done in your cerebellum. The vestibular nerve is the nerve that that takes the impulses of balance. The auditory nerve, the one for hearing. Okay, let's have a look, Colin. You've got a question here
Oh.
in our next. No, I'm talking about the question that
Oh,
you've
I
asked.
thought I was almost
No,
getting
unfortunately, our learners are just
excited about the learners.
listening today.
Yeah, very
Yeah.
few schools, and we know because of the trial exams.
Yeah.
But for those who are still
I think
writing,
we have to move on a little bit. We've got little time, and we still need to talk about homeostasis.
yeah, we're starting with homeostasis.
Yeah.
now.
So
this
let's
is
just see here.
there's another way of seeing how you can get a question there. Identifying, first of all, again, the parts. A, definitely it's the round window, and that can be confusing because you need to know the round window. And what does the round window do? It absorbs all those pressure waves that is in the cochlea, and if that doesn't work, then especially if you have been in an environment where there's sound so loud that when you go into a room where it's quiet, then it seems like everything is still singing in your ears, and that is because the round windows
echoes
shine.
in your ears. And by the way, if you listen to loud music, it's very bad for you.
Oh, yes.
But you can actually feel the loud music, the vibrations coming out of the round window into your down your eustachian tube into your throat. That's just a point of interest.
Right, and D part is the cochlea. Now it says, name the receptors that are found in part B. So now we have there, part B, the semicircular canal. And we've just said, make sure that you know the receptors, and that is the cristae.
Cristae, yes.
And because, why is it not the macula? Because the macula, it's found in the utricle and the saccule, right at the bottom of your semicircular canals. And then explain the consequence to the human body if part C is damaged. Now, part C is the auditory nerve. What happens if that is then damaged? Of course, no impulses from the cochlea can be transmitted to the brain, and
So you'll be
no
deaf.
hearing. Yeah,
No
no
hearing.
hearing can occur because nothing will be interpreted. And part A is the round window. So what will, if part A becomes hardened?
Yeah, you will have these echoes that we talked about. It won't be able to transfer the vibrations to the middle ear and out down the eustachian tube. quite interesting.
Yeah, so please know the statement and the reason for that as
Yes.
well. That is where that comes
Okay,
in.
there's our next part. Oh, no,
whoopsie.
sorry.